think prompt engineering means finding the perfect sentence to ask an AI model. That's not really prompt engineering. Prompt engineering is the process of designing instructions, context, examples, constraints, and output formats so that an LLM produces useful and reliable behavior for a specific task. And there's an important distinction. We're not trying to get one impressive answer, we're trying to build a system that produces useful behavior repeatedly. That's an engineering problem. Traditional software often gives us deterministic behavior, give a function the same input, and we generally expect the same result. An LLM is different. Its output depends on the model instructions, context, examples, conversation, state, and generation configuration. So our job isn't to control every token. Our job is to reduce ambiguity and constrain the problem. And there's another important point. Prompting techniques are model dependent. A technique that works well for one model may not produce the same behavior on another. So experienced AI engineers don't memorize magic prompts. They understand the principles and evaluate them against the model they are actually using. First, be clear and specific. Write about AI leaves almost everything undefined. What topic, what audience, how long, what format, what's the expected outcome? Compare that with explain React to junior backend developers in 3 bullet points, include one practical example, and keep it under 100 words. Now we've defined the topic, audience, format, example requirement, and length. The model has less room to guess. The practical rule is if a requirement matters to your application, put it in the prompt. Don't make the model guess requirements that your application already knows. Second, separate instructions from data. When prompts become complex, mixing everything into one paragraph makes them harder to reason about. You can clearly separate instructions, context, examples, and user input. For simple prompts, plain text delimiters may be enough. For complex prompts, structure delimiters such as XML style tags can make boundaries much clearer. The syntax itself isn't magic. The principle is make the structure obvious, and don't assume that one ordering rule works universally. Different models can respond differently to instruction placement. Test the structure that works best for your model and task. Third, give useful context. A common prompt starts with, you are a world-class expert with 20 years of experience. Sounds impressive, but it doesn't magically give the model 20 years of experience. Useful context is concrete. What's your product? Who is the audience? What are the business rules? What information is available? What outcome do you need? The goal is to give the model information it can actually use. Concrete context beats motivational language. Fourth, show examples. Suppose we are building a support ticket classifier. Zero shot prompting might simply say, classify this ticket. But if the classification rules are subtle, examples can make the expected behavior much clearer. Refund requested, billing password reset. Account server is down. Infrastructure now classify the new ticket. That's few short prompting. Examples demonstrate not only the task, but also the format and decision boundaries. And here's the engineering lesson. Don't just add more examples, add better examples. Examples should be relevant, diverse, and representative of the cases your system actually encounters. Another important principle, don't only tell the model what not to do, tell it what you actually want. Instead of don't return invalid JSON, say return exactly one JSON object. Matching this schema, instead of don't use markdown, say return plain text using 3 short paragraphs. Positive instructions give the model a destination. Negative instructions only describe obstacles. And if your application expects structured data, define the output contract. Category, confidence, reason, define the allowed values. When your model or API supports structured outputs, use them. But remember, a prompt is not a validation layer. Your application should validate the output before passing it into business logic. When the task becomes complex, break it into logical steps. Extract, classify, validate, respond. Task decomposition makes each step simpler, observable, and testable. More context doesn't automatically mean better answers. Give the model relevant context, not maximum context. Use tools when the model needs external capabilities, search, database, calculator. And don't over-prompt. The goal is the smallest, clear specification that reliably produces the desired behavior. Finally, treat prompts like code. Version them, create test cases, add edge cases, measure quality, compare versions. The real question isn't, does this prompt look good? The real question is, does this prompt reliably improve the metric we care about? So if you remember only one thing from day 9, clear specifications beat clever prompt tricks. Because prompt engineering isn't about making an LLM sound impressive. It's about making an AI system reliable enough to ship. And remember, prompt engineering is model dependent. The best prompt isn't the one that sounds clever. It's the one that measurably works for your model, your task, and your users. Day 10, system prompt versus user prompt. Because once you know how to write instructions, you need to understand which instructions belong where. See you on day 10.